Decomposing fractions into partial fractions, Part 2a. Case 1. Distinct linear factors. When decomposing any fraction into partial fractions, you must remember to check that the degree of the numerator is strictly less than the degree of the denominator. The next thing is to fully factorize the denominator. In this case, we see that x squared plus 2x minus 3 can be factorized into two distinct linear factors, namely x plus 3 and x minus 1. Since the denominator consists of two distinct factors, this fraction can be decomposed into two parts, a fraction with denominator x plus 3 and a fraction with denominator x minus 1. In order to determine the numerators of these expressions, we need to remember the following. The degree of the numerator must always be smaller than the degree of the denominator. So, since x plus 3 is a first-degree expression, the numerator must be an expression of degree 0, in other words, a constant, say a, and similarly, x minus 1 is a first-degree expression, and the numerator must be a constant, say b. How we solve the values of a and b we will see in a later video. Case 2. Distinct quadratic factors. In this example, we see that the denominator has already been fully factorized into three distinct quadratic factors. None of these factors can factorize further into linear factors. Since the denominator consists of three distinct factors, this fraction can be decomposed into three parts. A fraction with denominator x squared plus 3, one with x squared plus 1, and the last x squared plus 2x plus 4. Since x squared plus 3 is a second-degree expression, the numerator must be a first-degree expression of the form, say, ax plus b. Again, x squared plus 1 is a second-degree expression, so the numerator must be a first-degree expression, say cx plus d. And similarly, since x squared plus 2x plus 4 is a second-degree expression, the numerator must be of the form ex plus f. Case 3, repeated factors. Please see the next video, Decomposing Fractions into Partial Fractions, Part 2b.